salts and pH. First thing I want you to know is that if you have a strong acid or strong base, the conjugate they make is very weak. It's a weak conjugate base, conjugate acid. If it's a weak acid or weak base, they will have a strong conjugate base, conjugate acid. So they're opposites. So why does that matter? So I have a solution of sodium acetate. So I've got sodium and acetate in solution. It's a solution, so I've got water. I need you to know that all the positive ions, they're always the conjugate acid. The negative ions are always the conjugate base. So think of where it comes from. So an acid, a conjugate acid, comes from a base. A base makes a conjugate acid. So all we're going to do when it comes from a base is add OH. So NaOH is the base that made that conjugate acid. A conjugate base comes from an acid. An acid, we had a hydrogen ion. So HC2H3O2 is the acid that made the conjugate base. NaOH is a strong base. So a strong base makes a weak conjugate acid. HC2H3O2 is a weak acid. And a weak acid will make a strong conjugate base. In solution now, we have a very strong conjugate base. It means that it is looking to accept a proton. It is a strong conjugate base. It's a base, so it's a proton acceptor. The only thing it can accept a proton from is water. So C2H3O2 minus is going to react with water. It's a conjugate. C2H3O2 minus is a conjugate base, so it's a proton acceptor. So it'll make C2H3O2 plus OH minus. So the ion is reacting with the water to take away water and make more OH. Since it is producing OH, this salt solution is basic. You don't need to know a number, you just have to know it's basic. The reaction is your proof. So the next one, we have ammonium chloride. So there's my beaker. It's got ammonium floating around. It's got the chloride ion floating around, and it's got water. I need to figure out which one of these is stronger, because that's the one that will react with water. This is my conjugate acid. This is my conjugate base. The acid comes from a base, so it's coming from NH4OH. The base comes from an acid, so it's coming from HCl. This is a weak base, so this is a strong conjugate acid. HCl is a strong acid, so it's got a weak conjugate base. So that means my strong conjugate acid is going to react with the water. So my conjugate acid reacts with water. An acid is a proton donor, so it donates the proton, becomes H3O plus NH3. The presence of, we change the H2O to more H3O plus, so that would make this solution acidic. All right, what about if we have something like KCl? K plus Cl minus H2O. Conjugate acid comes from KOH, strong base, so it's a weak conjugate acid. Conjugate base comes from HCl. It's a strong acid, so it's a weak conjugate. Since both of these are weak, neither of them reacts with water, and the pH stays neutral because water isn't being changed. Water isn't gaining or losing protons, so the pH stays neutral.